Greetings everybody. Today we'll talk a little bit about surface area. Before you watch this video, you should have looked through the GeoGebra book that I posted on Schoology. You were supposed to do the first 6 activities in that book, and we will continue progressing through that as we learn about surface area. So in addition to that GeoGebra book, I did want to provide a couple application examples for you to try to apply some of the things that you may have recognized or discovered through the GeoGebra activities. So here we go. The first example I want to do is finding the surface area of a prism. So as you may recall from previous surface area conversations in previous years, the last time you may have talked about surface area would probably have been 7th grade math or math 7-8, whatever you took. The formula is the same, 2 bases, so 2 times the area of the base, which is capital B right there. Capital B stands for area of the base, as opposed to lowercase b, which is just a one-dimensional base of a shape. Capital B is area of the base. Okay, so 2 of those plus the lateral surface area, LA, not the city. The lateral surface area is calculated by taking the perimeter of the base times the height. That's the most efficient way to calculate the lateral surface area, which is the 4 sides here that are not a part of the bases. There's 6 sides total. You have 2 bases here on the top and the bottom, and then your lateral faces are the 4 additional faces on that prism. Now, you don't have to use the top and the bottom as your bases. You could use the sides, you could use the front and the back as your bases, and you would get the same answer. For my calculation today, in this example, I'm going to use this as a base, and therefore I'll use this as a base as well. And so let's go through the calculation here. So the surface area of this prism, 2 times the area of the base. So that means the surface area is going to be 2 times the area of the base, which is 5 times 5. So that's 2 times 25. Plus the lateral surface area, which is the perimeter of the base times the height. Well, what's the perimeter of the base? Well, 5 plus 5, this is a square here, so these are all 5s, so the perimeter of the base is 20. And what does h represent? H represents the height, and the height is always the distance between the bases. In this case, it's 10. Now, when most people think about height, they think of a vertical component. In this case, the height is a vertical component. It's going up and down. But the height that you plug in completely depends on what you use as your bases. For example, if I was to use these 2 sides as my bases, then my height would be right here. It would be the distance between those 2 faces, and that would be a horizontal component. So don't think height as vertical, think of it as the distance between the bases. So in this calculation, it would be 10. So here for surface area, I have then 50 plus 200. So my final surface area will be 250 centimeters squared. And that's how you would calculate the surface area of that prism, that rectangular prism. One question some people ask sometimes about prisms is, what if the base is something besides a square or a rectangle? Well, that happens. You could absolutely have a base that's a triangle. You could have a base of a prism that's a hexagon or a pentagon. And just like we did here, you'd have to find the area of that base. Now here it was a simple calculation of 5 times 5 equals 25. You would just have to find the area of whatever the base is and use the appropriate formula based on the shape the base is. All right, now that first one was a little bit of a softball. Here we have a pretty complex one. It's a composite example. It's a composite figure, meaning there's 2 figures clumped into one, and there's intersection between them. So if you can imagine this figure in the picture here, we have a cylinder, which was the other figure that you guys learned about today in your GeoGebra exploration. And inside of that cylinder, we have a prism right here. And it's a rectangular prism. It's a 6 by 14 there. And so inside of this cylinder, we have this kind of prism going through the middle of it. In other words, this is a hollow space. There is nothing in that space. There's like a prism size hole going through the middle of that cylinder. Now, when you think about calculating the surface area of this entire figure, of course, you're going to have to find the surface area of the cylinder. But then if you can imagine, there's a hole right here on top, and there's a hole right here on the bottom. So when you're calculating the surface area of this entire figure, you take into account the cylinder, but then we're going to have to add on 4 of the sides of this prism. So that the lateral surface area of the prism will be a part of our surface area calculation. Because there's no top and bottom, those will not be a part of our final surface area for this shape. In fact, we'll have to subtract out 2 bases here because there's a hole here and there's a hole here. So we'll have to subtract those out towards the end of this problem. So let's start looking at the cylinder. For the surface area of the cylinder, we have 2 times the base, so that's 2 times the area of the base of the cylinder. The radius is 14, so that's pi r squared. So pi times 14 squared. And there's 2 of those, okay? Plus pi times diameter times height. Where did that come from? So you may recall from one of the activities in GeoGebra that the lateral surface area is calculated that way. Pi times diameter is the circumference of the cylinder, which also happens to be the width of the lateral surface area. If I rolled it out, it would be the length of the circumference of the base. And so it would be pi times 28 times the height of the cylinder. And the height of the cylinder is 14, the distance between the bases. So that will go in for h right there. When I simplify this, I get 392 pi for the bases, and I also get 392 pi for the lateral surface area. So altogether, my surface area of the cylinder is 784 pi square feet. Okay, let's take a look at the prism now. So because this prism in the middle of the cylinder does not have bases, we do not have to consider that in our calculation. We really just need the lateral surface area, perimeter of the base times the height. The perimeter of the base, if we can look at that right here, it's a 6 by 14 rectangle. That's 14, that's 6. If you add those 4 sides together, you will get 40. And the height of that prism is still 14. 40 times 14 equals 560 square feet. So let's think about how I would calculate the total surface area here. I'm almost there. So far I have the surface area of the cylinder. I have the surface area of the lateral surface area of the prism. I know that I'm going to need to add those together to get my total surface area, but there's one adjustment that we have to make. Remember how I said in the beginning that there's a hole up here and there's a hole up here. So in addition to adding those 2 highlighted numbers together, I need to subtract out the area of the top and the bottom of that prism. Luckily, that's a fairly simple adjustment. I will just have to add those 2 numbers and then subtract 2 times the area of that rectangle up top, which is 6 by 14. So I'll subtract 2 times 6 times 14. And if I add together this number right here, this number right here, and then I subtract out this product right here, my final answer should be approximately 2855 square feet. And that's the answer for that one. Okay, hopefully that was a helpful discovery, an example going through that. And there's a couple questions in Schoology that I'd like you to try out. As always, make sure you reach out, schedule a conference if you need anything. Miss you guys, hope you're doing well, and hope to talk to everybody soon. All right, guys, see you later.